entire class.
Hey, class, okay, settle down. Here's what it might look like. This would need some work before this is great as a resource, as a summary, as a solution. You can't necessarily expect to use it exactly the same way when you make your screencast. So having the solutions in place to begin with, of course, is not going to be super helpful. So if you've got solutions in place already, take those out. And trying to pack all of this onto one page is probably a bit excessive. So if this were mine, I might unlock the picture, and I might try to crop this. You can crop, right? I didn't. Oh, I did. I just imagined that. Oh, that's terrible. Okay. Okay, so hey, that's all right. No need to panic. We are going to screen capture the part we want. A bit at a time. New page. Ready to go. We don't need the snapper anymore. It's only a little bit messed up. But this would be a better place to start your screencast solution. So ideally, as you're talking, you can illustrate some common problems and talk through what you have seen done incorrectly here. And this is your chance to talk about after you've talked about the physics, talk about the representation. Or maybe you want to do it in a different order. But often there's going to be a tension in your classes between learning the representation and learning the actual physics. I want, if at all possible, I would like you to strive to use some form of handwriting, if you can manage it. Maybe if you turn your mouse way down, it'll help. Or you go to the DTSE computer lab and use the actual smartboard. Piece of cake. But let me mention this again. The rules of making a force diagram are going to be incredibly complicated to a certain segment of your population. And when you're talking basic dynamics, total force, making a force diagram, that's a lot to keep in your mind at once for a normal person. Arrows up, arrows down, the relative lengths. And you don't want to be in the situation where what you're doing is talking about, you make your classes about how to make a force diagram. You can be a little sloppy on the representations you accept if people are thinking about physics. If you understand the idea of force as an interaction between two objects and the total force exerted on an object by other objects, the force diagram gets easier. That being said, here's a good time to talk about conventions for your class and remind them that if they're going to draw a battery, the plus side is this. And remind them that it's conventional to make straight angles, and a light bulb properly looks like that. And you know, folks, it's cool if you draw something that looks like this, because that does represent what we're talking about here. But here's a chance to talk about what might be the better way to do it. I would make your students wait a little bit for the actual solution. Don't make your screencasts as verbose as mine. Have a plan, have a note next to you, perhaps what you're going to cover, have slides prepared. Don't give them just a solution right up front. They should have to listen to you blah blah for a little while. So when we're done recording, go down here to our recording doohickey and click start.